Painting masks by hand works, but it takes forever. What if you could create your masks automatically based on other masks or objects in your scene? That's exactly what PP scripts are for. They calculate your masks automatically in seconds, no matter how complex your map gets. And yes, scripts are also the most intimidating tool in procedural placement. But today I'll show you how to use them without needing to become a programmer. At the end of this video, you will understand how PP scripts are structured, how to read and use the built-in functions without memorizing a single line of code. And you will learn how to build your own script that automatically generates masks for forest, roads, buildings and splines, all in one go. Hi Virtual Landscape Architect, I'm Nadine, and my mission is to build the most complete and practical place for farming simulator modding. Let's pick up right what we left out in part 2. On the Asia map, the PP rule called createAllMasks. Let's go to the PP menu and open the Rules tab and have a look at the createAllMask rule. You can see here that it has several masks assigned, and a bit further down we have some additional input fields. Up here we see that it has a script attached to it, GenerateAllMasks FS25. Let's switch to the Script tab and have a look at the script. The Script tab shows all the scripts which are in the Data, Maps, Procedural Placements folder in your game installation path. Open the dropdown like I did here. The first thing you'll notice in the script at the top are the argument definitions. These are exactly the input fields and mask slots you just saw in the rule. They look like comments because they start with a double dash. But if the line starts with argument and then colon, this will be used in the PP rules menu to build the input fields. We will use that later when we build our own script. These inputs from the rules menu are what the script needs as a starting point. Next we have here the PGMasks variable. It has game install path in it, but this is only a placeholder. That's not something you can actually use. You need to replace it with the actual path to your map. One thing to watch out for here is backslashes. In Windows, backslashes are used to describe path to a file, but in Lua, a backslash has a special meaning, so you either need to double them, like they did here, or you have to replace them with forward slashes, which is maybe the easier option. Now let's look at the first actual mask. This is GE11. GE11 is assigned the result of the PP function PPTerrainHeightMapMask new. That's how it usually works. You call a function and the result gets stored in a variable. If you've seen my scripting basics video, this will look familiar. If you want to go back and watch it, I will link it for you. So what does the PPTerrainHeightMapMask do? This function will create a mask based on the terrain height, just as the name suggests. In this mask, higher terrain points will be more white and lower points will be darker. Right after that, we use the function PPSaveMask that writes a mask to disk. This function takes two arguments. The first is where to save the mask, which is here a combination of the PGMask path, which we set over here, and the file name. The two dots over here mean that the two texts are concatenated. And the second argument is which mask to save. And this is the GenHeightMask, which we filled here with that PP function. Now, how do you know what parameters a function expects? You don't need to memorize that. Let me show you. I will delete the opening bracket after the function name and then type it in. And then we get a small pop-up window, which is also called Code Assist. This shows on the top line all the arguments which a function needs. Below that, we have a short description of the function, and on the third line it says here 1 of 2. That means that you can use the arrow keys to scroll through your code and check each parameter with its description. The current parameter you are looking at is also written in bold on the top line. So let me use the arrow key to walk over to the second parameter. So now the PP mask is bold, and down here it says 2 out of 2, and it tells us here that it is the mask to save. This works for every PP function. So whenever you're unsure what a function needs or does, this is your first stop. Unfortunately, this is only available in the built-in script editor by default. As we said, the mask will be stored in the pgmask path and named GE11. Let me quickly jump into Windows Explorer and show how that looks like. Here we have it. This black and white gradient reflects the terrain height. The mountains at the edge of the map are lighter, as you can see, and the middle, where the terrain is lower, is darker. Now back to the script. Let me open the script also in Notepad++ to show something else. In Notepad++ or a lot of other text editors, if you double-click an entry, all the other entries of the same text will be highlighted. So here I double-click GE11 and also the file name and the other occurrences where we use this mask are highlighted. So that makes it very easy to track down your script where this mask or this variable is used multiple times. Unfortunately, the built-in editor does not do this, so depending on what you're looking at, one or the other might be the better option. Let's look at the next mask, which is the Gen Sea Level mask. This mask uses the GE11 from the previous steps and puts it into the PPCreateThresholdMask. This function creates a threshold mask. So what does that mean? We saw earlier that the GE11 shows the gradient between black and white. And you may remember from the RGB video that white represents a value of 255, while the value for black is 0. If you haven't seen it, I will leave a link for you. And the height mask currently has a lot of different values in this gradient. With the threshold mask, we define that each value above or below a certain value will be white, and the rest will be black. No gradient anymore, just black and white. As the name suggests, the mask is meant to show the sea level, and in the function it says that all values below 15 will be white. Again, after that the PPSaveMask is used to save the mask, and this time the name is Gen Sea Level Mask, PNG. Let's check that out in the mask. Next up is the slope mask. GenSlopeMask is first created with the function PPTerrainSlopeMask new, which is working similar to the height mask. It doesn't have any additional parameter, but instead of height, this one captures the steepness of the terrain. So for this one, flat areas will be darker and steep slopes will be lighter. But we don't want a gradient here either. We want to know, is this slope too steep, yes or no? So the result is immediately passed into the createThresholdMask as in the previous step. The difference is that this time the threshold value comes from the input field slope angle min, which the user can set in the rules menu. Everything steeper than that angle becomes white. And then we have something new here. In the next step, PPSignedDistanceMask is used. This one is a bit more abstract, but it is really important, so let me explain what it does. Imagine the white areas of your black and white mask as islands. A signed distance mask will draw a border around those islands with a width of a given number of meters. A positive value draws the border outside of that white island, and a negative value draws the border inside the white area. Here we have a negative value of minus slope distance blend. This is again a setting which is coming from the input arguments here. So we are drawing an inside border. And the numbers 255 and 0 will create a fall-off gradient. The first value is the start value at the border of the white island. Here we will have 255, so white. And then to the inner end it will create a gradient to 0, namely black. This is done to create a softer transition zone at the edges. The result is then saved as slope inside mask. Here. You'll also notice a few lines that are commented out here. These are alternative calculations that were tried and left in for reference, but they don't run in the current version of the script. But you can still get ideas from them for your own scripts. And then both the slope mask and the slope inside mask are saved again with PPSaveMask. Let's look at them. This is a slope mask, and here on the slopes on the top right, you can see if I switch to the inside mask that it is not the full white areas, but only the borders of these white areas. Now we get to the roads. The Gen Road mask is created with the function PPProjectObjectsMask. This function takes a group of objects from your scene and projects them straight down onto the terrain to create a mask. Think of it like shining a light from directly above and capturing the shadow. We will see how that works exactly when we use it on our own map later. After that, we calculate road borders using PPSignedDistanceMask, the same function we used for the slope. Here it is used 3 times to get different border zones. One shrinking inward by 1 meter, one expanding outward by 1 meter, and one expanding outward by 2 meters. In this case, the borders don't have a gradient. With all 255 values, the borders will be completely white. And then in the next step, PPCreateMask is used. This function can be used to combine 2 other masks with each other. Depending on the operator in the middle, they can be added or subtracted or whatever from each other. So here we have a minus and here we have a plus. This is the function to merge 2 masks together or punch a hole into one mask using another mask. Let's have a look at the road masks. The road mask will be used to paint a texture below the road. You might ask, why do we need a texture on the road? There are 2 reasons. In FS25, the roads are mostly placed as terrain decal without a collision. In that case, you will use the collision and ground attributes from the terrain below. Grass or something like that is not solid, so it impacts driving. You need something solid like asphalt or concrete below your roads. Second reason, if your road object disappears in the distance because of the distance blending, the road will still be visible for the player because of the painted texture. The next section, acres, should now look already a bit more familiar. We use the input field acres mask to get the mask with acres painted on them, and then use PPSignedDistanceMask to create a 2 meter border, and again an 1 meter outside border, and then save these 2 masks as PNG files. The path masks down here are similar to the road rules. We use again the PPProjectObjectsMask function on the defined include nodes for pathways, save it as a PNG file, and then calculate a border with PPSignedDistanceMask and save that too. The next section is interesting. Here, the Gen Meadow updated mask is calculated. You see that this mask takes the input parameter meadow mask as a basis and then subtracts a lot of other masks from it. Remember that we saw in part 2 that the PG meadow mask was completely white and only the Gen Meadow updated mask made sense? This is where this happens. From the completely white mask, we cut out the other masks like acres, bushland mask, sea level mask, roads, road borders, and so on. And at the end of these operations, PPClampedMask new is used, because adding and subtracting mask values can push them outside the valid range of 0 to 255. This function simply clips the values back. Anything below 0 becomes 0, and anything above 255 becomes 255. Think of it as a safety net. And then the same pattern we had for the meadow repeats for the forest. We use the painted forest mask from the input parameter as the basis and subtract a lot of other masks from it. Here we additionally calculate a border zone and an inside zone using PPSignedDistanceMask, so that later rules can place different things at the forest edge versus inside the forest. This is the forest updated mask, and this is the forest borders. The forest borders inside mask doesn't exist, it has not been used apparently in the final mask. And that's the full script. You see, it's a lot of functions, but once you see the pattern, So create a mask, optionally transform it into something else, save it. It's always the same rhythm. Okay, now that we understand how the AsiaMap script works, let's switch over to the mod map from part 2 and build our own mask generator script. Let me load this map. I have prepared this map a bit since the last video. Let's quickly go through my changes. You can see here there is now a hill, and behind it we have a small depression in the terrain, which could be a small river and lake. I have a few objects placed on the map which serve as makeshift roads and buildings, and we have some splines. We will use all of this to demonstrate the different mask types. I've also repainted the forest mask. Last time we painted on the Gen Forest update mask directly. But this time we want to calculate it and use the PG Forest as a basis. I also added a field area. As you can see here, I did not paint it. Let me do that. But here you have it. And I also have some objects like this here in the forest. Let's start by opening the Procedural Placement menu, and there the Scripts tab. Look at the blank Lua. This is the empty template script that comes with the game, and it's our starting point. It will be used when we add a new script. It has nothing in it except some green lines with examples for input parameters, which we could set in the rules menu. So let's click Add Script and give your script a name. I will call mine Generate Masks Nadine. And OK. You'll see it automatically creates a new rule based on the blank Lua and opens it. One very important thing to note: this new script was created in your base game folder, and there under Data, Maps, Procedural Placements. Currently, this is necessary in order to see the script in the PP menu. You have to create a backup somewhere else, otherwise you might lose your script with a game update. You have been warned. We'll use this script as a base and build our script step by step using copy and paste from what we've already seen on the Asian map. That way you don't have to write everything from scratch. You only have to understand what these functions do so that you can adjust them to your liking. So let's look at the script from the Asian map. We first copy the input parameters and the PG mask path so that we have the base. We go to our new script and we overwrite what is already there because we don't need these example input parameters. First, let's set up our output path. I'll copy the path to my mask folder from the Windows Explorer. Remember that you have to use forward slashes or double backslashes. Also, make sure that your path ends with either one forward slash or two double backslashes, just like I have that here. Because if you forget that, your mask will be saved in the folder data instead, and the word mask would be part of the file name. We don't need that placeholder and the two dots here anymore, so we delete that. Then we can already save our new script. We can now test if we can select it in the rules menu. So go to the createAllMasks rule and see if we can select it. Yes, we can. And you see that we also have the input parameters from the Asian map over here. Might be blank for you. It is not blank for me right now because I already did some testing. So you might need to fill all these masks, in your case, like this. You don't have to set these include roads and paths, we will do that later. Now let's add our first mask. We'll start with the depression, because this depression here gives us already something nice to work with. Let's assume there is going to be water in our final map. So I copy the height and sea level lines from the Asia script. Let me go there. So we have these parts over here, the comment for height and sea level. And we copy this into our own script, paste, and then we have the basis. Remember, the PPTerrainHeightMapMask creates a gray gradient from the terrain, and the threshold mask makes it either black or white based on our settings. Here in the threshold mask, 15 was used on the Asian map. That might not be true for our current map. So let's find out. An easy way to check the terrain height at a certain point is to use the terrain sculpt mode and use Ctrl R. Let me show you. When I hover with the brush and press Ctrl R, this field over here for the replace value will display the terrain height. So if I do a few tests of this, if I would expect the waterline here, so that would be something for 48 or 49 for me. So I can set this value in my script. I will use 48. Now everything below 48 will be white in my mask. Let's also rename sea level to water level. So this is the variable, and we copy it and use it here. And we also use it as the file name. To recap, we have now the height map generated by the function PPTerrainHeightMapMask that is saved with PPSaveMask as the file genHeightMaskPNG. Then we reuse this height mask in the next section and put it into the threshold mask to create a water level mask for everything below height 48. And then we save this to the mask file genWaterLevelMask so that we can use it in our rules. Let's do a test run to check if our settings work so far. Save the script, then switch to the Rules tab. We don't want to run all the rules now, so just this one. So deselect everything and only activate the createAllMasks rule. Apply changes. Let's quickly set the input parameters if necessary. And then we save our map file. Before we hit execute for the PP rules, again, please make sure that you have a backup of your map as always. And then we click the execute rules button. And now let's check the results. We cannot select this mask because we renamed it and we have not introduced it yet to the Mask tab. So let's do this. Procedural Placement, Masks. And then I go to the script, copy my name from there. And then I rename the sea level mask to water level mask. Double click on the file and also select the water level mask over here. You can see already that it did create something on the mask. Apply the changes and now we should be able to select it. Yeah, we do, but it doesn't load. So maybe because we just introduced it. So let's reload the map. Here we have it. So if you imagine, we paint that now with an underground for the water so that we can place a water plane on it. That would look already great. You don't have to do these test runs all the time, but I wanted to make sure that you know how to check your results. And hey, thank you for sticking with me so far. PP scripting is not the easiest topic, and you just got your first own mask working. If you're enjoying this, don't forget to like the video, subscribe and hit all those nice little buttons below. That would help me out a lot, but it will also help you not to miss any of my future content. Thanks a ton! Also, if you have any questions or feedback, or have wishes for future videos, please leave them in the comments below and I will make sure to respond. Let's continue now with the slope mask. Again, we copy the slope mask from the Asia map. Now we also copied some lines which were not in use. We can remove these, we don't need them. So here we first use the PPTerrainSlopeMask function, put that into the GE11 and then we put that into the threshold mask to create a black and white mask for everything which is above the slope angle min, which is again up here in the parameters, slope angle min. It is an int input. Int stands for integer, so it is a number input field. You could write the number in the script directly, like we did here, or you could put it in an input parameter. That would also work. Depends on your preference. So let's just try that and add the water level also as an input parameter. Let's copy this line with the slope angle min and then change it to water level. So now we created a new integer input for water level and we can use this instead of the 48 up here. Paste this. So now we have created an input field. Let's save this and check if we can use it in the rule. Here we have it. It's now set to 0. I will set it again to 48, what we had also in the script. Apply the changes. And for the slope angle min, I have 40 degrees. So this is not a must. You can also keep the 48 here and put the 40 degrees immediately in the script, as I said. So what will happen now? Everything which has a slope steeper than 40 degrees will be white on our slope mask. Back to the script, we have a few more lines for the slope to go through. We have now a new mask which is called GE11, where we use PPSignedDistanceMask to create a border for the slope which we have calculated before that. And the border has an inside border because of the minus, and it has a width of slope distance blend, which is again a setting. Let's check what it has. 5 meters. And then we save both the slope mask and the slope inside mask to a file. Let's do another quick test to check the results. Save if you have not done it yet and then execute the rules. So here you can see we get now these white patches around the hill and here also at the edges of the water. And let's also check out the inside border, slope inside mask. So here you can see that it has a fall off. It has the same size as the other one, but at the immediate border it's white and then it fades down to black. So let's now do something with the roads. I will copy again the functions from the Asia map, including the lines for the borders. So let's look at that. First, we use the PPProjectObjectsMask to calculate the GenRoads mask. That was the function which acts as a light shining downwards and casting a shadow. This function uses the input argument nodes include roads, which is defined at the top of the script. This is defined as a nodes input. That means it will take node ID values from your scene. And this true here means that it will also take the sub-items of the node we select in the scene. The third setting is pixel per meter, which is usually 1. So let's save our script and then select the nodes for the roads. The Rules tab gives us the few options for working with the input node. We have Add Selected, Remove, and Select in View. Let me just make that blank. So let's now select the roads transform group here and click Add Selected. We can also add more than one transform group, so I can also add the buildings, for example. This will give the buildings the same border and underground as our roads. Of course, you could define separate masks and rules for the buildings, but in order to make the video not extra long, I leave it like this. Apply the changes and then go back to the script. For the borders, they are doing a lot here. Let me think about what I want. First, I want to have a mask which is a bit smaller than the actual road object, so I can paint a solid asphalt underground for the roads, which is not visible when you are on the road. And I also want a border texture for the road border itself. So in order to do that, I need to shrink the Gen Roads mask a bit. And to achieve this, I will add an inside border of 1 meter with the PPSignedDistanceMask new function. And we can use this line from the Asia script for this, because that does exactly that. And we don't want to fall off here, so we leave the 255 in both places. So in order to be able to paint something on this inside border with a rule later, we need to save it as a mask. The script does not do this yet. So let's grab one of the other save lines down here. Copy, paste, but change it to work with that mask. Save this mask as this file name. So, okay, now we get ourselves a border mask of -1 meter. But let's name that road mask borders, not inside. I don't need that because I don't have inside plus outside different borders. Like this. Then we said we want to use this mask to make the Gen Road mask a bit narrower so that our underground texture isn't visible. For that, we need the PPCreateMask function. Remember, this one is used to calculate masks against each other. It is already used on the Asia map, so let's copy this line and adjust it. We don't want to create a new mask over here, but instead we want to change the Gen Roads mask. So let's copy that. And the second parameter will be the new Gen Roads mask borders. But we need a minus here in the middle, because we have this mask already, and we have this mask already, but we want to cut out this mask from that mask. So you can think of it as a subtraction. But if I'm working with black and white mask with no gradient, I prefer to use the AND or AND NOT options. We can check that. So here you have all the options what you can have in this function, AND or AND or NOT, or a lot more. I did have some issues with the plus and minus delivering unexpected results, because Lua number calculations are not always 100% accurate out of the box. Have you ever seen a full silo or pallet in-game displaying 999 instead of 1000? This is exactly the same thing. So I will use AND NOT here. I think it's also better to understand. We want everything from the Gen Roads mask and nothing from the Gen Roads mask borders. What is currently white on the Gen Roads mask borders will become black on the new version of the Gen Roads mask. And then we need to save the new mask. So I copy this here and put it in the next line where we already have the save function. But here we want to save the Gen Roads mask, both as the file name and also as the mask. We can also delete the other rule up here where we already saved the mask. We don't need to do it twice. And then I remove the other lines, what I copied, because I don't need them anymore. Let's save the script. And now let's move on to the pathways. On the Asia map, they also had pathways, but there the pathways actually were objects, just like the roads. We can't use that here on our map because we only have splines. Splines have no width to them, so nothing would be painted if we try to use the PPProjectObjectsMask. Instead, we have a script in our scripts list which is called Paint Mask by Spline Group Lua. The name is promising. It suggests that it can paint on a mask based on splines. But when we look at it and scroll down, we see that this script is unfinished. There is a comment which says that the layer ID still needs to be copied to a mask. I went through that script and had a look. It can actually paint a texture along a bunch of splines, similar to the built-in Paint Terrain by Spline script, but this one can act on more splines at once. Unfortunately, it cannot paint a mask. But we want a mask so that we can automatically remove the pathways from our forest, meadows, and so on. So I went and created a finished version of that script. You can download it via the link in the video description. The script is called PPSignedDistanceMask Lua. And while you're at it, you can also download the other script from the video description already, because we will use that in a few minutes. Download the script and save it into your scripts folder. This script is a bit different than the other scripts which you downloaded from me, because this one will not create a new menu entry in your user scripts menu and run on its own. Instead, it will provide a new PP function which we can use in the PP menu, just like the other PP functions we already used. In order to be able to use it, we need to tell our current PP script that this function exists. It will not know about it by itself. We can do that by adding a source line to our current script. So go somewhere to the top of the script, maybe below the arguments, and type source, opening bracket, double quotes, and then the name of the script file, pp spline to mask Lua, double quotes, closing bracket. And what this line does is it tells the editor to also load this Lua file, and so that it knows the contents of this Lua file, and then it can use the function which is in that file later in the script. You can also copy that line from the top section of my script. There I included also a small description about how to use it. And here you have the source line which you can copy into your own script, of course without the double dashes. My script also has an example of how to use it. Here under number 3 it says how to call the function. Let's copy this into our script. We are working on the pathways. Here's the new line. And we want our mask to be named Gen Paths Mask. And then in the spline group node IDs, that should be coming from the setting. That is here, nodes include paths. So let's copy that and put that down here. For the width setting, we could either fill a number here or make it adjustable by adding a number input argument for the rules menu. I will add a number input just like we did for the slope angle and the water level. So I copy the water level line and paste it, and then rename it to path width. Copy that and put it down here instead of the width, and then save the script. And now we also have to set our new settings in the rules tab. Go there and find the nodes include path. Then select your path splines in the scene and click on Add Selected, just like we did with the roads and buildings. And for the width, I set it to 4. Oh, it's not visible yet. Let me apply changes and then go back and forth. There it is. Let me set that to 4 and apply changes. And now we also want to save that mask to a file. So we copy one of our save lines from here and copy the gen path mask into the file name and also here in the mask input. Save your changes. And I would say now it's time for another test run. Save the script, save your map, and then maybe reload your script environment because it might not know about the new script yet. And then execute rules. Let's check out the gen roads mask. Let me hide the road objects and buildings so we can see it better. So here we go. These are our masks for the roads and the buildings. And the road borders look like this. And you see it also has created borders for the buildings. And the path mask. That has worked also. Nice. Oh, but the borders did not work. Oh, I didn't create any. So yeah, of course it didn't work. Let's copy some lines for the borders quickly. I will do it like this we had for the roads. But this time, what was the name of the mask? Oh, save. Mask. Path borders. This one. Copy that. Okay. This is the borders. And I want the borders to be calculated with the distance mask based on the path mask, of course. But I don't want it inside border, I want it outside border this time, so I delete the minus. And then I save this. Save. And let's do the run again. Now we also have borders for the path. Let's move on to our acres mask. Most likely you created your fields with the built-in field toolkit because it's the easiest way. The field toolkit can also paint your fields with the terrain detail cultivated, like I did here. But it will not paint a mask for you. And this is why I created the other script. The other script is called PPFields2Mask Lua. And if you downloaded it already and put it into your scripts folder, you are good to go. If not, please do it now. The implementation and usage of this script is similar to the PPSplines2Mask. We have to add a source line to our script in order to be able to use it. Like this one. And we can again copy the source line from the script itself because I put it in as a comment. Here it is. And here is also the usage. Mask name equals PPFields2Mask new. Copy that. Okay, let's replace the mask name by the actual mask. Oh, as you can see here, the PG Acres mask, this assumes that it is a painted mask, but we are not going to paint it, so we should rename it to Gen, so that we see it is a generated mask. I will also write that with a small a, because the other Acres masks also have a small a down here. By the way, that's not the same in Lua, be aware. And then we also have to rename our mask. So it's not PG Acres, but Gen Acres. And select that. Apply changes. And then we can use this in our script instead of mask name. The function PPFields2Mask doesn't need any additional parameters because it will find your fields directory automatically, just like the built-in field toolkit. So we are done with this function. And since we don't use the input parameter from the acres mask anymore, because we calculate it now, we can also remove this parameter line from the script. So we don't need this line anymore. And we also have to save this mask. So let me again copy one of the save lines. and fill it with the correct entries and save the script. I think we have enough generated masks now. The Asian map creates a few more, so let us just copy these script parts. What do? They also have an acre border, so let's copy this. But we have to change it, because here they use the acres mask, which was the input parameter, which we don't use anymore. We replace it with genAcres, and that's it. We just leave it as it is and save. Yeah. And now we have the meadow and forest update scripts. Let's first do the forest mask. We copy all these lines, put it at the end of our script. Oh, I did not copy one letter. Okay, this is where we use the create mask a lot of times and always subtract something from the painted forest mask. As I told you in the beginning, I have changed the map to use the painted forest mask, the PG forest instead. So let's see what they are subtracting here. First, they subtract the acres mask. We don't use that, so we have to change it. Change it to genAcres. Next thing, they subtract the bushland mask. We can leave that. They also subtract the sea level mask. We don't have that. We renamed it to water level. Let me get that. Next thing, they subtract the roads mask and the road mask borders. We also have that. Yes, same name. Then they subtract the path mask and the slope mask. But as I told you earlier, I don't like the minuses, so I will replace all of these by and not, just like we did over here. And then we have the PP clamped mask at the end as our safety net. But since we use the and not, we technically shouldn't need it because the value can never be outside 0 or 255, but we can as well leave it there. And then we also have some forest borders. Here we have an outside border of forest border distance. Let's check that out. 4 meters. Yeah, but I don't want an outside border. I want an inside border. I don't want to make the forest any bigger. So I will change that to minus. And I also will change the fall off to be in the other direction. And same here. Also here we have a clamp mask. Why are they doing it again? I think that one is not necessary. So, and then we save the forest borders, forest inside, and we also save the gen forest update. So that was the forest. Let's do the same with the meadow. This is now our final step. We calculate the gen meadow updated mask. Let's first copy the rules from the Asian map. The meadow here until the save line. So remember that the PG meadow mask on the Asian map started completely white and then all the other masks were cut out. Our PG meadow is currently black because it was copied as a black map from the Asia map. Here it is. So we could now paint it white manually, but there's a more elegant way to do it. We need a completely white mask as a starting point because this is then our default. Let's generate a completely white mask. We do have a function for this, and this is called PPConstMask new. With this function, we can generate a mask with a fixed value. This is the same function I also used in my copy script in part 2 to generate the black mask files. So let's make the PG meadow mask white. We copy paste the first of the meadow lines and adjust it. to what we need. So instead of PPCreateMask, we change it to PPConstMask. Const for constant. And then we remove the bracket and re-edit to get the code assist. And then we see that this mask expects only one value. And this should be 255 to get a white mask. And then we copy one of the save lines and save it as PG meadow. Was that also the name of the mask? Like this. Yeah, so now we have the PG meadow, which is filled with the fixed mask over here. And then we put that into the first createMask function. And then we start subtracting all the other masks. We start with the forest mask, which is coming from the input parameter, and we can leave that. And then we subtract the acres. We need to change that again to gen acres. Bushland, sea level, need to change that. Roads mark borders, path mask, and slope mask. And then we have again a clamp and a save on that gen meadow updated mask. Let's save this. And then we are done with our PP script. Let's do one more test run with our script to see if all these masks are generated correctly. Save, and then run the PP rule createAllMasks again. Since our last test, we added the generated acres mask. Let's check that out. Here we have it, also the one here in the forest. Yes. And the borders for the acres also looks good. And the generated forest. You can see the forest has now cutouts where we have the water and the roads and the pathways. It's a bit hard to see here, like this. And the field. And also the buildings we have down here. And all of that was calculated automatically. No painting by hand. Let's check out the meadow. So here we have all these cutouts, but also the forest has been cut out. Before we run the complete PP setup now, I want to go over one more thing, the BLOCKMASK. Sometimes you have already detailed out an area manually and you don't want to destroy that by any procedural placement running over it. And this is exactly what the BLOCKMASK is for. It excludes area from procedural placement. There are two ways to paint on the BLOCKMASK. You can select that while you paint textures or foliages, or you can do it in the procedural placement menu. Let me first paint a texture. I will use asphalt over here. And here we have a checkbox which says block procedural. If you tick this box, it will also paint the BLOCKMASK while you paint the texture. Let me just paint something. And this is also the same with foliage painting. So if I select terrain foliage paint mode and select small dense mix, for example, I also have block procedural down here. So let's now look at the BLOCKMASK. You see it has actually painted something on the BLOCKMASK. We see two things. First, the mask has different colors. We see some red here, green, and a yellowish color where the two overlap. Second, it did not fill the area completely where I painted the foliage. Why is that? The colors show that the BLOCKMASK is actually an index mask. This means it does not only have black and white as layers, but it actually has several layers where each layer gets its own color, similar to the farmlands. And the second thing, With foliages, I've always had this issue that it does not fill the area completely, so I don't use it that much. But the good thing is you can also paint manually on the block mask. In the PP painting mode, you can tick these boxes: block texture, block foliage, block mesh. If I select block texture and paint something, you see that it paints in the same color which was also created for the texture earlier. If I only select block foliage and paint, you see that it's green. If I say texture and foliage, we have this red, also like we did over here. And if I say block mesh, it's again a different color. If I select everything, like this. To summarize, each combination of these checkboxes has its own color on the block mask, so the color of the block mask shows you what is actually blocked in that area. You can also use Ctrl R to check what is blocked. So I hover over it, Ctrl R, and now it highlights block texture. Down here, texture and foliage, down here, all three. So let's now run the procedural placement rules. I don't bother adjusting the rules right now anymore because we did that in part 1 and 2 already, but of course you should go through the rules and adjust them to your liking. Let me go to the procedural placement menu and to the rules tab and enable all rules. And let me quickly go through them and check if I need to adjust something there because of our changes. With T underwater, we have to change it to water level mask. T acres, we have to select Gen acres. And clear grass channels, let's use that to clear the grass from our water mask. Apply the changes. And then we are ready to execute the rules. Save, and then execute. And this is our result. Let's go through it. Okay, we have some texture on the slopes and no foliage. We have the water level and the underground texture for the water. We have the forest as we had it in part 2. But this time we do have cutouts for the roads and the buildings and the fields and also the pathways, as you can see here. But when I look at the pathways, I see now we do have a border defined, but obviously we don't have a texture defined for the paths. So let's do that. Go to the Rules tab again. And then let's check out the path border rule. Do we have it here? We can right click it and say duplicate. Then it will add a new one at the bottom. We can rename that over here, remove the borders and the 0 and call it path. We change it to be on the path mask instead of the border mask. And then we can define a texture for it. Let's use dirt gravel maybe. Apply the changes. And then we can also move that rule to another place. We can use these arrow buttons over here to move it. So let me put that next to the other path rule. Here it is. Apply changes. What I also see down here is that obviously the path rules was painted after the road rule because the path border is now on the road. I would like the road to be the main object, so I would like the road to be painted after the path. I can do that by moving the road rule a bit further down. So apply. And let's run the setup again. Okay, this looks better. It's certainly not perfect. I would definitely make some more adjustments if I'm working on my real map, but it's definitely already a very good starting point. We have the forest, we have the border for the forest where it has some bushes but no trees. And we have this meadow with some bushes in between, what we also defined in part 1, sorry. And we have the forest, which we already looked at in part 2 with all the detailed foliage on the ground. Great. A few final words about troubleshooting. Working with procedural placement is not always sunshine and roses. Sometimes the PP scripts don't work like you expect them to. And most likely, it's your fault, sorry. Often because you made a small mistake while copy-pasting and not realizing it. And troubleshooting is hard because often it just silently fails and you don't know why. So here are my top tips for troubleshooting. First, check your spelling. One very important thing is capital and small letters. As I mentioned in Lua, Gen Acres with a capital A is not the same as Gen Acres with a small a. If you use a capital letter in one line and the small letter in the next, these are two different things. That's one thing. Second, sometimes the Giants editor is also being weird. So save, close the editor, reopen it and try again. It has solved things for me in the past where I spent hours investigating, so don't underestimate that. It only takes a minute to reload your map. And if your error is in the masks being generated, you can use the automatically created debug masks. In the PP painting menu, let me zoom out a bit. In the PP painting menu, you can go through the list of cached masks down here and check until which point of your script your generation worked. And then you might get an idea where it goes wrong. So here we have meadow, forest, and a bit further down, it says the functions which we used. So here we can have a look at the PPTerrainHeightMapMask, the threshold we created based on it with the water level, then the slope mask, again a threshold on it, and so on. You get the idea. So you go through this list, you check what worked, and then you see what did not work. And that's the point where you have to start your troubleshooting. And the fourth tip is you can also comment out parts of your script and do test runs only up to a certain point to see where it worked and where it didn't. So let's wrap it up here. Today we achieved a lot. We started by walking through the complete GenerateAllMask FSNAS script from the Asian map. Now you know what every PP function in there does. You can read the function arguments with code assist. You find threshold values with Ctrl+R. And you can follow how a mask flows through the script. And then we built our own script from scratch on a real mod map, water level, slopes with inside borders, roads with shrunken borders and underground texture, path from splines, fields, and the calculated forest and meadow masks, all by simply subtracting what we don't want from a base mask. Along the way, you also picked up 2 of my custom PP functions for splines and fields. You learned how to use the BLOCKMASK to protect handcrafted areas. And you got my top tips for troubleshooting when something doesn't work the way you expect. And remember the promise from the beginning? Painting all of these masks by hand would take hours. And you'd have to redo it every time your map changes. And with this script, it's done in seconds. And that's the real power of procedural placement scripts. That's it for today's video. Thank you so much for sticking with me. I really appreciate your time. If you enjoyed this, don't forget to like the video, subscribe and hit all those nice little buttons. That would help me a lot, but it will also help you. Please click here for a related video or here for another one you might like. Don't be a stranger. See you next time.